Hello U10s and welcome back to Mathematics. In today's lesson we're continuing with our topic of properties of geometric figures, and what we're doing is we're applying similar triangles. We're building off some of the skills that we looked at the end of last lesson and doing a few more examples where we need to actually find missing sides using similar triangles. Now in today's learning intention and success criteria, what we want to do is to be able to apply similar triangles and understand what a scale factor is first of all, and use similarity to find missing lengths in triangles. So let's get into it. At the end of last lesson, we talked about this concept of a scale factor. So here, it's a quick definition. The scale factor is a number required to multiply the side lengths of a triangle to enlarge or reduce its size. So last lesson, we talked about similar triangles. Similar triangles is when you have a triangle where they don't have the exact same shape, but not necessarily the same size. So for example, if I took this triangle here, I know it's badly drawn, and I replicated it again, and then I enlarged it, that's an example of a pair of similar triangles. We have the exact same shapes. All of the angles are exactly the same. So these angles are exactly the same, and these angles are exactly the same, but they don't have the same size. And so what the scale factor is, this tells me how many times, what do I have to do to the side lengths of my smaller triangle to multiply it to become the biggest triangle? And so this can be found by dividing the corresponding sides. And so we also developed a formula for the scale factor. So the scale factor was the image length. So how long is one particular side in my enlarged version, and then divided that by the original length. How long is the corresponding side of the similar triangle in my smaller triangle? And so what we did was we went through the following steps. We identified two corresponding sides in a similar triangle. Then we divided the two sides. So we usually pick the larger sides over the smaller sides, and this result is called the scale factor. And then what we did as a final step was, what we did was then we multiplied or divided by a corresponding side to find the missing side, So what we're going to do in this lesson is actually apply these skills into a few further examples. So let's have a go at a couple of examples of this. Example 1, applying similar triangles. A homemade raft is made of two sails with measurements in the angles in the triangle shown in the diagram given. So if you have a look over here, we have a little raft and they've got two sails. We've got the first one over here and we've got the second one over here. And we've got given a few angles inside and we've got a few measurements as well. Let's have a look at this questions. First one, part A, explain why the two sails are similar. Now this is where we need to use some of our knowledge of the similarity tests from last lesson to actually help me answer these questions. We can see that these two triangles have the exact same shape, but they're not the exact same size. And one of the ways that we could have shown this is by noticing, actually, we've got these two triangles have two pairs of exact same equal angles. So here, if you have a look here, I've got this angle is equal to this angle. And the other one is we've got a 90 degree here, and we've got a 90 degree here in my second triangle. So what I can say is, well, actually, these two triangles pass, well, if you look from last lesson, I'm going to actually go back to my notes from last lesson. This actually passes the first test. We've got two angles of the triangle being equal to two angles of another. And so here, I'm just going to write here for why I know these triangles are similar. So why are the sails similar? The triangles have two pairs of equal angles. And that is test number 1 from last lesson. So it passes that test 1. It has two pairs of equal angles, corresponding equal angles in both the triangles. And that means that these two triangles are similar. They have the exact same shape, but they might not have the exact same size. So that's the first part. When we are asked to explain why things are similar, we just need to identify what kind of test from last lesson might be applicable here. Usually this is actually a fairly common one to use, two pairs of equal angles in the two triangles. Okay, part B, find the scale factor of the sails. So here we want to find how many times bigger the bigger sail is compared to the small sail. And what we need to do is we need to find two corresponding sides, or two sides that match up in the two triangles. So if you have a look here, well, I've got these two measurements in my smaller triangle of 3.5 and 2. We want to figure out if there's any side in the bigger sail which matches up with that. Well, if you have a look, the only measurement I have in my biggest sail is this 5 meters. And if I match up where the angles are and where the sides are, this 5 meters matches up with this 2 meters. And so these are the two pairs of corresponding sides. So what I can say is the scale factor is going to be equal to, I'm going to take my biggest size, bigger sail measurement divided by my smaller one. So it's going to be 5 divided by 2. 5 divided by 2 is just 2.5. And so here, this is the scale factor I'm going to be using. So in order for me to get my measurement of my bigger sails, it's just 2.5 times larger than the measurement in my smaller sail. Okay, that's part B. We found the scale factor. Now part C, find the length of the longest side of the largest sail. So notice here, what we want to do is find the length of this side over here. Now, in order to do this, what we're going to do is we're going to actually find what side matches up with this longer side in my smaller triangle. And if you have a look over here, that matches up with my 3.5 over here. So what I'm going to do is I'm going to go for my longer sail. And let me try rewrite this a little bit cleaner. My longer sail, well, that is just going to be that 3.5 measurement from my first smaller sail, but then I'm going to multiply that by the scale factor. I'm going to multiply that by 2.5 because that's how many times bigger the bigger sail is compared to the smaller sail. So here, 3.5 times 2.5, I'm going to do that on my calculator. 3.5 times 2.5, 8.75. So that tells me that in my bigger sail, the longest side of my biggest sail is 8.75 meters. So that's how we can use our scale factor to help us find missing sides in our triangles. And this is very similar to the stuff that we looked at the end of last lesson. We're just going to do a few more examples to apply this particular skill. Okay, so that's the first part of the first example. Let's have a look at another one. Now this is where we've got a few combined triangles. So here we've actually got a diagram where we've got two triangles inside the same one triangle. So let's have a read of the question. A ramp is supported by a vertical stud, AB, where A is a center of CD. It is known that CD is 6 meters long and the ramp is 3 meters high. So if you have a look here, what we're imagining is along this length here, this is a ramp. So here we've got a ramp. And we've got a few things. Firstly, the ramp is supported by a vertical stud at AB. So AB in the middle here, that's a vertical stud that supports the ramp. A is in the center of C and D, and we'll actually use that in a moment. And CD, they tell us, is 6 meters, which is what they've got down here. And the ramp is 3 meters high. So ED at the back here is 3 meters. Okay, first question. Using the letters given, name the two triangles that are similar and explain why. Now what I'm going to do here is I'm actually going to draw out the two triangles. So if you notice here, we actually can split this diagram into two separate triangles that overlap each other. The first one is a triangle at the front. So here we've got A, B, and C. So I'm going to draw here. This is C, B, and A. And so here we've got this measurement, that angle, right angle there. We don't have any measurements yet about A, B, and C yet, but we're going to get into that in a moment. Actually, let's actually do a few things first of all. Well, first we can work with this. The only piece of information that I can work with is that A is the center of CD. So A is in the middle of CD. So what that tells me is that AC has to be half of 6 meters. So that can actually tell me that this measurement here is going to be 3 meters. Other than that, we don't actually know very much else, so I'm just going to leave it at that for now. Now, hopefully you can also notice there's a bigger triangle, CDE, which is overlaps with our first triangle. So here I'm going to draw a bigger triangle. So here that is CDE. It's also got a right angle. We know that this measurement is 6 meters and this measurement is 3 meters, and that is it. Now, we want to name the two triangles and explain why they are similar. Now, if you have a look here, there's actually one piece of information that I haven't included yet. Notice here, they actually have a common corner at C. Both of these triangles have a common corner or vertex at C. And so what that means is that actually, both of these have this exact same angle at C. So just like the first example, we've actually got two pairs of equal sides. So these two angles are exactly the same. So this angle at C is exactly the same as this angle at C. And also the other thing is they both have right angles here. So both of them are 90 degrees there. And so that means that both of them have another equal angle over here. So what I'm going to write is, actually, that tells me that triangle ABC is similar to, well, let's match them up. And this is the notation that we looked at in the last lesson. A will match up with D, so that's going to be similar to D. B is going to match up with E, DE, and C is going to match up with C. And so here, these are my two similar triangles, and the reason why is that we've got two equal angles, just like the first example. Two equal angles. Two pairs of equal angles, maybe I should write that. Two pairs of equal angles. And because we've got two pairs of equal angles, that means our two triangles are similar. Okay, that's the first part. We actually showed that the two triangles are similar, and here we actually need to notice that because the two triangles overlap, we end up getting this common angle at C right there. Okay, let's have a look at the next part. Find the length of the stud AB. So what we want to do now is we want to find this length over here, AB. Now what you notice is hopefully that actually these two triangles, because they're corresponding, means that we can actually use similar triangles and a scale factor to help me figure out how long AB is. If you look at my two triangles, AB is going to match up with DE. So I know that has something to do with my 3 meters, but before I actually can do that, I need to figure out what the scale factor is. So what I'm going to do is I'm going to find two pairs of matching sides in my triangles and then find the scale factor. So here, scale factor. If you remember, it's my image length divided by my original length. And if you have a look here, I've actually got this pair of matching sides down at the bottom, 3 meters and 6 meters. So what I'm going to do is I'm just going to write the bigger one divided by the smaller one. 6 divided by 3, which will give you 2. So what this tells you is that my two triangles, they are actually, in order to get from the smaller measurement to the bigger measurement, I need to multiply by 2. And so what this tells me is that if I want to go backwards actually, so notice here, what we want to do is we want to find the length of AB. AB is in my smaller triangle, and so what I'm going to do is I'm going to actually divide the measurement in my bigger triangle. Now, if we had done the steps that we did from the previous step, so I'm going to, previous example, I'm going to show you what not to do for this one. So if I wrote AB is equal to, well, the corresponding side was 3. So I'm going to write 3 times 2, which was the scale factor. This is what we would have done if we did the example in the first, just did the exact same steps as the first part. That will actually give me a measurement of 6 meters. But if you think about that for a second, does it make sense that AB is 6 meters? Well, if you have a look at the diagram, if this was 6 meters, that would actually mean that it's bigger than this ED over here, like that length. So that obviously tells me that it is not quite right. So this is not right. So instead of doing this, I'm actually going to divide. So I'm going to have AB is equal to 3 divided by 2, which is 1.5 meters. And that actually looks a little bit better. It actually looks a little bit more correct, because if you have a look over here, AB needs to be smaller than ED. So here I'm going to get that AB is equal to 1.5. So that's how we can apply similarity in the similar triangles to actually help me find missing sides. So let's do a quick summary of what we looked at today. In today's lesson, we went through the idea of a scale factor again. And so we noticed that the scale factor was the image length divided by the original length. And by finding this scale factor, we can actually use this to help me find missing sides of two similar triangles by either multiplying or dividing. So in these questions, what we wanted to do was firstly figure out why my two triangles were similar. And often the case is going to be that they've got two pairs of matching angles. And if we've got two pairs of matching angles, that means our two triangles are similar. Then we're going to need to find the scale factor between the two triangles and either multiply or divide depending on whether or not we want to find the measurement in the smaller triangle or the larger triangle. So that's it for today's lesson, Year 10s. If you have any questions, feel free to ask me a question on Google Classroom or send me an email. I'm more than happy to try and answer your questions. But until next lesson, Year 10s, I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye.